Hi everyone, welcome to another installment of Organ Technology. Today's topic is amplifiers, and we're also going to take a little side trip of sorts to a little town called Dinuba and visit an Rodgers organ from the past that had a big impact on me in my early days. Now, I have to state right up front, these are not how-to videos. You should not mess around with electronics unless you know what you're doing. I am presenting this for information and entertainment purposes only. Learn about electronics before you start digging around in some piece of old equipment. Thank you. All right, amplifiers. Now, why are amplifiers so terribly important? Now, we looked at the 33E project last week, and I had swapped out all of the individual Rodgers S100 amplifiers for a single Crown 4-channel amplifier. It was easier to work with that Crown amplifier in terms of adding the digital effects and sound processing that I want to do to enhance the sound of that instrument. And it also gave me an opportunity to separate out the amplifier away from the Leslie speaker on the tibia. Well, it turns out that the first channel on that Crown amplifier doesn't work. And when I opened up that Crown amplifier, it's not tinker friendly in there. So I decided, well, I'm going to go ahead and fix the amplifier in the Leslie speaker and just leave that as is. Now, why did I think it would be a good idea to take the amplifier out of the Leslie? Well, this is in a regular Leslie, like a 147 model that you might see on a Hammond organ, that speaker system has a very special amplifier in it because it has a very special type of speaker in it that requires that special type of amplifier. And so you really don't want to mess with that kind of thing. The type of Leslie speaker that is on the Rodgers 33E is a standard full range cone with a horn drum on it that channels the sound. And in an upcoming episode, I'll show you all about how that thing works. So it uses just one of the standard Rodgers amplifiers, so it would have been perfectly okay to simply pop that out and power that speaker from the Crown amplifier. The main reason I thought that that would be a really excellent idea is because on Leslie speakers, both the audio signal and the line current to run the motor for the spinning drum go through the same cable, and this sometimes introduces some noise issues. So I was figuring, an easy way to get around that, right? Well, any rate, that didn't work out, and so I went ahead and did some obvious repairs on the amplifier, and we'll take a look at those in just a second. Now, amplifiers, especially when we're dealing with analog technology organs, there's amplifiers all over the place. Every time you do something to the signal, you have to amplify it back up because that processing weakens it. So we are running our oscillators, we run them through the keying circuits. Well, now the signal's a little weak. So you got to boost it back up before it goes through the stop switching, and then you got to boost it back up before it goes through the filters. Then you got to boost it back up before it goes into the preamp, and then which boosts it back up before you go out to the main amplifiers. This is true again with all of the digital effects devices that I'm using for chorus and pitch shifting and reverb on this instrument. But those little amplifiers are built into those devices. So I bring the signal in, it's processed, and then there's an amplifier to boost it back up to what it was before. So having kind of a basic understanding of how an amplifier circuit works is a really handy thing to know when you're trying to troubleshoot and deal with these old instruments. So let's take a look at some drawings I made. Get the microphone out of the way here. So here we have some really conceptual drawings. These are just meant to show you kind of the basics of how these, what the transistor does and how it's configured into the amplifier circuits. Now, we're dealing with Class A type amplifiers. Most kind of audiophile types agree that of the transistor amplifiers that Class A is kind of the best. but we'll talk about why we would use a different type in a minute. So here we have our basic concept of an amplifier circuit. We have our collector, our voltage source coming into the collector. Branching off of that is our output going to the speaker. We have our audio, our weaker audio signal coming in here, and it is it's going to open this transistor up to flow to ground, and that will raise and lower the voltage here at the output. Now, obviously, this by itself is just going to give us VCC to the speaker, and that really isn't what we want. The other thing about this is that transistors, unlike vacuum tubes, tend to act like a switch. When they get a signal here, they tend to just open up. And so we need additional circuitry to kind of get this thing to behave more like a valve. And you may have heard a vacuum tube amplifier being referred to as a valve amplifier. And that's because a tube tends to behave exactly the way we want it to for an amplifier. The signal coming in and the signal going out are proportional. Well, you got to do a little trickery with a transistor to get it to do that in a satisfying way. So now we have some resistors hooked in, and we've got some capacitors hooked in, and here's why. These two resistors, which are basically are a voltage divider along the collector emitter path, control the current flow, limit the current flow through from the VCC and to ground, and this gets the transistor to kind of have to work a little harder, and that will allow our signal to come in, and then kind of this will, work more proportionally. The other issue we have to deal with is that the transistor has a barrier voltage. It doesn't do anything until it has more than 0.7 volts coming in at the base. So we branch this other voltage divider circuit with two resistors this way so that we can get a constant, just a skosh under 0.7 volts here, so that when our signal comes in, the transistor is ready to go. So we get a signal in here, we get current flow going this way, that raises the voltage this way. And that's basically how our type A amplifier works. Now, if you think about it, if we look at this, we've got a constant DC voltage going through here, which means we would have a constant DC voltage potentially going this way and this way. Well, we certainly do not want that. So we have these capacitors, and they're not, in this case, a frequency filter, but are a DC blocker. So what happens is, over here, any DC current trying to get back towards our source is going to be blocked by that capacitor. It's not going to go anywhere. The alternating signal of our audio is going to head on right through. It will be 90 degrees phase shifted because of the charge and discharge characteristic of the capacitor. Then it comes in here, opens up that transistor. We get flow this way, and then we're getting voltage this way. But we still have that pesky little DC voltage that might be trying to sneak in over here. So again, we have another capacitor at this point doing exactly the same thing, and our signal comes this way. The DC voltage is blocked, but our audio signal heads on through, again 90 degrees shifted out of phase because of the charge and discharge characteristic of the capacitor. So the amplifier that was in the Leslie speaker, when I started looking at it, I noticed that there was another one of these pesky little cardboard tube capacitors. These are always suspect, and this capacitor was sitting at this point in the amplifier circuit. So the amplifier was working okay, but it seemed to have a little bit of noise issue, and it wasn't as clean as I wanted it, and maybe there was some issues. So I had to hunt pretty deep on the Rodgers technical site to locate the schematic for this one. This is an S101D amplifier. The circuitry is very similar to the S100's amplifier that I like so much, but this one isn't quite as sophisticated as the S100. So our input is over here. This is our input capacitor. We have our bias adjust, and that takes care of this barrier voltage issue here. So it gives us just exactly what we need right here. So that is something that we kind of try to leave alone because you've got to have an oscilloscope to really adjust that correctly. It also has a hum adjust. There's additional filtering to take care of any unwanted hum, and that does work pretty good. But let's go underneath here and take a look. Now, the biggest part of any amplifier is the power supply. So we got our transformer here, and here's our rectifier circuit, and here's our main filter capacitor to take that rippled DC that comes off of our rectifier circuit and smooth it out to make it nice and straight. And here's the replacement capacitor for this. Now, normally this big capacitor would have been through this hole and sticking up on the amplifier, but instead it was lashed to the interior of the chassis here and wired in. So with the replacement capacitor I did the same thing. This capacitor is 2500 microfarads and this one's 22, but for what it's doing it should work just fine. So next time we take a look at this, I'm gonna reinstall it in the Leslie speaker, and we'll talk all about the Leslie speakers and how those work on an upcoming episode. Now, as I said, Class A amplifiers sound really good and do an excellent job as far as what our ears are wanting to hear. The unfortunate thing is that they're not very efficient. In fact, typically they're about 30% efficient. So you have to have a power supply that is much, much larger than the output of the amplifier, because you have to overcome that, the inefficiency of the amplifier itself and have enough power going into it. So you got a lot of power coming in and not as much power coming out, but as far as amplifying the signal and doing a beautiful job of it, they really, really work beautifully. So there are, of course, other types of transistor amplifiers, B, A, B, C, and D. There's a lot of videos on YouTube to explore how those work. They get much more complicated. And then there's a lot of various specialty amplifiers, like what would go into a conventional Leslie speaker. So amplifiers are a very, very important part of any audio electronics. Even if you're looking at your component stereo system, there isn't just the main amplifier going out to your speakers. There's the preamp on your turntable. There's the preamp on your CD player. There's the the various amplifiers inside your equalizer, your switching, and so on and so forth. So the signal has to get boosted many, many, many times before you actually hear it. And it's important for all of those amplifiers to do a really accurate job of amplifying that signal. So the other thing I wanted to show you today in the realm of organ technology was an organ that had a really big impact on me in my early days, When I first got interested into the organ, I started hanging around at the various organ stores in Fresno, and in the 70s there were several of them, and there were a couple of them that were just a bike ride away. And one of those was Stevenson's Music Center, which was the Rodgers dealer. And of course, Rodgers was the company that I found that was making the big professional style instruments, and so I really, really liked that. And the folks at Stevenson were really wonderful to me when I was first exploring the instrument. I had, of course, taken piano lessons for many, many years. And they would just hand me a headset I could plug in and play to my heart's content. And I started figuring out how to work the organ and read music and transcribe it to the organ and all of that. And Dick Sensabaugh would come by once in a while and say, "Hey, what are you doing? Have you tried this?" and give me some good advice. Well, the first time I went in there, they of course had a Rodgers 340 theater organ, and I was absolutely thrilled. It looked like the organ at the pizza parlor where I had discovered the pipe organ, and it sounded like it, and I had a lot of fun playing that. But after a couple of weeks, it disappeared. And I was in there, basically every day after school. But a couple weeks later, I walked in, and I saw all these organ pipes. My eyes got big, and I walked down to the end of the room, and wow, there was this set of pipes and a console right in front of it. And I said, "Can I play that?" And they said, "Sure." And I sat down, and Dick explained that it was a pipe electronic combination organ. And I was just absolutely thrilled to play that. And in fact, that's the first time I ever played an organ that had pipes on it. The Model 135 was a really well thought out piece of equipment. You had two ranks of pipes, a Spitz flute and a principal, and then you had the electronics to back that up. And basically the pedal and the swell were all electronic, and the grate was pretty much all pipe, with the exception of the cremorne and the bass notes of the 8-foot stops and the Gemshorn and flute celeste. There was also a positive section that was a few stops that would play on the swell that were also borrowed from the pipes. Now, I wanted every organ I fell in love with when I was a kid. I wanted that 340 really bad, and I wanted I wanted this when I saw it, and then they handed me a bunch of brochures, and I saw other stuff I wanted, so I really couldn't make up my mind. But this little instrument is really a neat thing, and it still is a neat thing. And over at a little church in Dinuba, they have one. And I was called in to do some work. Some rats chewed through the cabling, and I fixed that all up. And the organ really, really needed to be tuned. And this past week, I went over there and did a tuning job on it. If we look at the racks here, we see some of the same things that we would see in the 33E. And some different things. The left bay here is the stop switching for all of the electronic stops. And then we have our preamp board where the signal from all of the keyers comes in, and then that goes out to our output panel, which has those same jack plugs. And if we look at the 1, 2, 3rd bays in, this is the diapason and flute keyers. And then we go to the 4th bay from the left, and we've got the keyer for the reed stops. There's a cremorne, a trumpet, and a fagot, and an oboe. And then, of course, we have over on the far bays and one bay in, we've got all of the oscillators that are providing the signal for this. To tune this, it's actually pretty simple. You just turn the cap on the induction coils, and that changes the pitch of the oscillators. So that was the first thing I did, was go through and tune all of those oscillators up, and the thing started to sound pretty darn nice. The second rack, if we look at the first bay to the left here, this is the electronic outputs for the bass notes for the pipe sets. The pipe sets only go to 4 foot, and then electronic notes, generated notes, take each of those down to 8 foot. So it completes the rank. The green circuit board is for the percussion stops. There's a carillon and a harp stop. And then we have the red panel is the transposer circuitry, so that the organ can be raised and lowered in pitch conveniently. And then to the far right we have some more of the stop switching that controls all of this. If we take a look inside the console, you'll see there's one great big giant silver box, and that is the power supply for the whole shebang. And if there was a weak point in this particular model, it is this. This provides all the power for the electronics, all the power for the combination action, and it has moving stop controls, all the power for the pipe valves, and there really should have been at least a separate power supply upstairs for the pipe valves. The cardboard shroud covers the expression and crescendo pedals, and then underneath that, this is the junction, which carries the keyboard information up to the stop switches that control the pipes. And if we go upstairs where all of the sound making stuff is, it's very tight up there, so I didn't get a lot of really great pictures, but we have some S100 amplifiers. We have the stop switching for the pipes. You can see a little bit of a wind regulator there at the bottom. And then over to the right, you can see part of an M13 audio speaker. And again, as promised, at a later episode, I'm going to do a bit all about these speakers in early electronic organs, because that is a fascinating bit in and of itself. The speakers were a super critical part of the whole system. And in the early days, you had to have the right speaker to go with the with the particular organ, or it was not going to work right. And then, of course, we have our 2 ranks of pipes. And as you know, tuning organ pipes is relatively simple. You have a sleeve that goes around the top of the pipe, and you can tap it up or tap it down to effectively shorten and lengthen the pipe, and that adjusts the pitch. So there you have it. Amplifier circuits, very important to anything producing audio, and an early Rodgers pipe electronic combination organ. So next time we're probably going to take a look at putting that Leslie speaker back together on the 33E and seeing how that sounds, and seeing if my repair work on that old amplifier actually did any good. So thanks for joining me this time, and we'll see you next time.